Now, where are we going to move to next? Something completely different. Do you remember that Oscar said that there was a kind of trade-off, or he implied that there was a kind of trade-off between CCS investment and offshore wind here in Norway? Well, he seemed to think that offshore wind would be the winner of that, I think you said. So to somebody who's going to put the opposite case, who is a real champion for CCS, carbon capture and storage, is the general manager of the Global CCS Institute. So let's say hello to Guloren Turan. Guloren.
Thanks very much, Nisha. Ladies and gentlemen, good morning. And I would like to start by thanking the Norwegian University of Science and Technology for inviting me to participate in this important conference. And it's both a pleasure and an honor to be here today. I am representing Global Carbon Capture and Storage Institute. We are an international think tank backed by governments, businesses, and NGOs, and our mission is to accelerate the deployment of CCS technology globally. Our headquarters are in Melbourne, and we have offices in 6 other countries. Ladies and gentlemen, we have a massive challenge ahead of us. Science, and specifically the IPCC 1.5 report released last year, tells us that in the next years, we are supposed to cut our emissions by half and eventually get to net zero emissions by the middle of the century if we are to avoid dangerous climate change. This is a groundbreaking conclusion. Renewables, energy efficiency, and other low and zero carbon technologies can get us to zero emissions. But to get to net zero, we need carbon removal. In fact, in all 4 of the scenarios that you can see, pathways that have been outlined in the IPCC report, all 4 of them have carbon removal. In fact, 3 of them have carbon capture and storage in significant amounts. The yellow area that you see under here in 3 pathways represents carbon capture and storage. So if we're to take a closer look at carbon capture and storage, what is it? Carbon capture and storage is a set of technologies that capture CO2 from large emission sources directly from the atmosphere, and it stores them permanently and securely underground. A unique feature of carbon capture and storage is that it enables addressing both the flow of emissions into the atmosphere, as well as the existing stock of emissions in the atmosphere, the concentration of CO2 in the atmosphere. This is one of the features that makes it quite unique. CCS can help us mitigate and address our climate targets in 3 different ways. First, it can help dramatically reduce emissions from power generation, as Oskar pointed out, as well as industry. In fact, in some sectors of the industry, such as cement and steel, it is the only option we have available today to deeply decarbonize these sectors. Secondly, as I mentioned, it can also help address the stock of emissions in the atmosphere by sucking CO2 out of air, either through direct air capture or through bioenergy combined with capture and storage, and store them safely underground, thereby leading to negative emissions. And finally, as Liv pointed out earlier today, it can help us produce zero-carbon hydrogen, which can be used as a fuel in industry, in heating, in transportation, and even in power generation. Now, hydrogen, when combusted, produces only heat and water and no CO2. As a result, CCS can open the door to a new energy future. So what is the status of this technology today? Today, there are 18 what we call commercial scale projects globally in existence, and there are 5 under construction, with some 20 projects big, large-scale projects in advanced stages of development. These existing facilities capture and store around 40 million tons of carbon dioxide per year. 2 of these projects are in Norway, your country being very much a leader in this technology. These are Sleipner and Snøhvit, which I'm sure Stephen is going to, from Equinor, is going to talk about in a little future, in a little bit. Plus, there's a very exciting full-scale project in advanced stages of development called Northern Lights, which aims to capture and store CO2 from 2 plants, a waste incineration plant and a cement plant in Norway. Plus, the project also aims to create create storage for CO2 service for the rest of Europe, potentially. There are also other exciting CCS projects in pipeline, both in the Netherlands and the UK. This is within Europe. I'd like to also underline that to date, more than 200 million tons of CO2 have been captured and stored deep underground globally. So we discussed how much CCS we have today. The big question is, how much do we need? Now, this is a chart of International Energy Agency, IEA's modeling, and they, in order to get to, this is their 2-degree scenario, and in order to get to 2 degrees, they have formulated that energy efficiency, renewable, CCS, nuclear, and fuel switching are all to play a role, and CCS, this blue wedge here, accounts for 14% of cumulative CO2 reductions between now and 2060. That means that we need to capture and store 4 billion tons of CO2 in 2040, reaching to 6.5 billion tons. Just to come back, the cumulative wedge, the total amount of CO2 that we are to store is 140 billion tons between now and 2060. If you could just keep that number at the back of your minds, I'll just refer to it in a second. Now, we discussed that there are 23 projects existing and under construction today that are capturing 40 million tons per annum. And I just mentioned that we need to have 4 billion tons captured and stored in 2040. That means that from 40 million tons to 4 billion tons, and that means 23 projects today to 2,000 projects in 2040. Ladies and gentlemen, we're talking about a scaling up of 100 times. That is the scale of the challenge that is ahead of us. One of the questions that I get asked often is, this is a lot of CO2, and do we have enough storage, enough space on the planet to be able to store this much? I mentioned the number 140 billion tons that we need to capture and store between now and 2060. Now, this is a map of global CO2 storage capacity, and you can see, and I'm sorry, it's a little bit small, but only in Europe, we have 300 billion tons, so that's roughly twice the amount that we need globally to capture and store CO2. And if we look at the global number here on this map, there's more than 8,000 billion tons. I think that's 8 trillion. So storage capacity is not a problem. The other point that people sometimes raise is, isn't carbon capture and storage too costly? Now, a philosophical response or an approach to this answer would be, costly compared to what? To save the planet, to save humankind, to avoid dangers, climate change? I would propose not. But a more pragmatic response would be, showing you here a cost curve, what's called a cost curve for different applications of CCS. I mentioned the versatility of CCS, And here you see different applications ranging from gas processing, from industry to power generation, and cement and steel production. And the answer is yes, in some cases, such as in cement, for example, or in power generation, it can be, as the cost of CCS can be as high as $100 per ton of CO2 avoided, but it can also be as low as $20 a ton, particularly in applications like gas processing, where removal of CO2 is actually an inherent part of the process, and you have a concentrated flue stream gas. In fact, IEA estimated that for less than $40 a ton of a CO2 value, CO2 price globally, 450 million tons of CO2 per annum can be captured and stored. So harnessing these low-cost opportunities would provide a solid foundation for scaling up CO2. So just to conclude, we discussed that the technology exists, that there is enough storage, and costs are not insurmountable. So what do we need to accelerate the deployment of CCS technology? In order to do this, what we propose is the biggest barrier is an enabling policy environment globally. That would mean, sorry, let me go to the slide, is putting a value on CO2, such as the carbon tax in Norway, where it doesn't exist. It requires an enabling policy environment. These are long lead time projects, so it needs stable and predictable policies so that project sponsors, developers, and financiers can invest in these projects with confidence. And finally, there needs to be an open and transparent engagement with the public. As the Institute, we're releasing a major report on policy priorities for governments. This is going to come in early April. And so I can conclude by saying, watch this space. Thank you.
Thanks so much, Guloren. So very clear there, advocate for carbon capture and storage. Were you convinced? Do you need further convincing? Hold your questions, think about them now, polish them up, because I'm sure she will be able to do good dueling with us about why CCS is so important.